Hello, my name's Terry. I'm a software developer, a teacher, and the founder of EverybodyCodes.com, and welcome to this beginning JavaScript course. We focus on computational thinking and problem solving geared towards a K-12 curriculum. Unfortunately, computer science is not being taught in our high schools, and yet these skills lead to some of the best paying jobs and careers in the 21st century. The fact is, whether you want to be an educator, a scientist, or an economist, or an artist, whatever you want to study in the 21st century, learning the basics about computational thinking is a valuable skill because computer science is virtually transforming every industry there is today. In this beginning JavaScript course, we assume you have no prior experience and we'll focus on the 25 key coding concepts to help you learn to code for the first time. Concepts such as variables, iteration, branching, functions, and much more. We look at problem solving, so we'll take the exact same problems you see in your math and science courses and in your business courses, and we will solve those exact problems. And we will practice, practice, and practice, because the only way to learn how to code is with the practice. The advantages of JavaScript are many. First of all, it's the language of the web, and it is ubiquitous. You interact with JavaScript all the time, every time you are browsing the web or you are on your mobile device. And JavaScript is highly interactive. Let's go ahead and take a look at EverybodyCodes.com, and we'll look at some of the examples of the problems that we'll be solving in this course. And we will be building these completely by hand. For example, let's take some very basic course. One of the first programs we'll write is add two numbers together. So let's go ahead and take these two numbers and add them together. And we can interact and change the numbers here and test our algorithm to make sure it's doing what we expect. And we can see we've just written a program that adds two numbers. So some of the more advanced problems, or let's go ahead and simulate rolling dice until we get snake eyes. So this is a statistics or probability type problem. Let's go ahead and roll the dice, and it took 6 rolls. And we can see now it took 17 rolls, and now it took 16 rolls, and now it took 1 roll. We rolled it on our first time. So here we are modeling a real-time event and simulating it with code or in our algorithm. Other problems might be, for example, let's go ahead and build a table of XY coordinates for a polynomial. So here we can represent our polynomial, and we got our start bounds and our increment. And we can actually build a table here, and we can plot this graph here. So we are actually writing this program. We're going to learn all the core concepts of how to write these programs to solve these problems that we do every day in our math course. And of course, we can enter a different polynomial and different bounds and get a different table. But the idea here is we can solve the exact same problems that we see in our classes without paper and do them here in a coding environment. Some other problems, for example, we can find the factors of a number. We can look at physics problems such as calculate the distance, the time in flight, and the max height for a projectile. Let's go ahead and look at the factors of a problem here. We can find the factors of 99. Let's go ahead and add a few other, let's find a different number, larger here. It's instantly finding the factors. So these are things, again, we're doing in our math courses. One of the more advanced problems we can see is find the sum of all prime numbers less than or equal to a certain number here. So here's all the prime numbers less than 100. Let's add them together. So we've just done that. Let's take this and let's make this a rather large number, closer to 10,000. And we've just found all the prime numbers less than 10,000. And this is something that would be unthinkable to do by hand. And it's a simple problem, but yet using computational methods, we can solve this and learn a lot about coding and problem solving. So that's some of the problems that we can do here, and we have much more. So at EverybodyCodes.com, we also have pseudocode or flowcharts that allow students, that help students understand what is the key computational approach here, what is the flowchart, and how we are writing and designing our algorithms. If you are a K-12 teacher or educator, we welcome you to contact us and use our curriculum. We provide extensive teacher training. For teachers, we will teach you how to code. We have a vast online curriculum and a growing database of problems, and we provide extensive support. We will set you up. One of the hardest things if you're starting a computer science program or computational math or just a code club is just setting up your environment. So we'll help you set up your PCs, whether you have Macintoshes or Chromebooks. We can set you up and get you started teaching JavaScript. So let's go ahead and get started. Let's learn to code, and welcome to this beginning JavaScript course. Thank you.